Good morning, everyone. My name is Neha Goyal. I'm the student of BSc Chemistry Honors first year. Today, I am here to make a presentation on the topic aromaticity. So, what are aromatic compounds? The compounds which resemble benzene in the chemical behavior and distinguish themselves from aliphatic or alicyclic compounds are called aromatic compounds. Means those compounds which are similar properties like that of benzene but differentiating themselves from aliphatic or alicyclic compounds. Here, aliphatic compounds means when carbon atoms together form a chain-like structure, and alicyclic compound means when carbon atoms together form a ring-like structure. Alicyclic compounds are having characteristics of both aliphatic or cyclic compounds. Example of aromatic compounds are benzene, naphthalene, anthracene, and phenanthrene. We all know that benzene shows electrophilic substitution reaction. Naphthalene, anthracene, and phenanthrene also show electrophilic substitution reaction. Means they are resembling their chemical properties like that of benzene. So, characteristics of aromatic compounds. They have high degree of unsaturation, which is suggested by their molecular formula. Unsaturation means either they are having double bond, triple bond, or ring-like structure. Means they are having some reactive sites in them. Here you can see that in all the aromatic compounds, benzene, naphthalene, anthracene, and phenanthrene, double bonds are present. Means they are having high degree of unsaturation. And the saturated compounds are those compounds which have only single bond between them. We can also calculate hydrogen deficiency index, referred as HDI. HDI is equal to number of hydrogen atom in saturated compound minus x plus y whole divided by 2. So, how we can calculate the number of hydrogen atom in saturated compound? By the formula 2C plus 2. Here, C means that the number of carbon atom present in the compound. X represent number of hydrogen or halogen atom in the given compound, and Y represents number of nitrogen atom. For example, benzene. Here, the number of carbon atom is 6. So, the number of hydrogen atom in saturated compound is 2 into 6 plus 2 is equal to 14. And number of hydrogen atom in the given hydrocarbon is 6. Means HDI is equal to 14 minus 6 whole divided by 2 is equal to 4. Means in the given compound there is a deficiency of 8 hydrogen atom. So the given compound will either have 4 double bonds or have 3 double bonds and 1 ring, etc. Now the second characteristic is they are having a conjugate system of double bonds. Means that the double and single bonds are present alternatively. Means that the pi electrons are present in conjugation. Pi electrons are under movement because the pi electrons are continuously moving. They are releasing some energy. Means they are releasing the resonance energy. Means the benzene ring having the less energy. We know that the less energy means high stability because energy is inversely proportional to the stability. Benzene ring have high stability due to the conjugate system. So they are resistant to addition and oxidation reaction because in addition reaction one bond have to be broken to form a new bond. So these reactions are resistant to addition or oxidation reaction because they are losing their conjugate system, and they are preferred to undergo electrophilic substitution reaction like halogenation, nitration, sulfonation, etc. So, electrophilic substitution reaction means when the weak electrophile is replaced by the strong electrophile. In electrophilic substitution reaction, conjugate is not lost, means that the double single bonds are present alternatively. Here, our hydrogen atom is replaced by the nitronium ion. The nitronium ion forms when the concentrated H2SO4 and concentrated HNO3 react. We get the electrophile NO2 positive, means nitronium ion. This nitronium ion replaces the weak electrophile hydrogen as H positive. Means in this electrophilic substitution reaction, our system is conjugate, means that the double and single bonds are present alternatively. Why we do electrophile substitution reaction? Because our benzene is having high pi electron density. That's why we are doing electrophilic substitution reaction. The next property is the molecules are generally 5, 6 or 7 membered rings compounds like furan, thiopene, pyrrole, 5 membered ring, and pyridine, 6 membered ring compound. Next property is the molecules are flat as shown by X-ray and electron diffraction method. Means when these compounds is shown by X-ray or electron diffraction methods, these all are planar structure. The next is they have high thermodynamic stability, which is shown by the low heat of hydrogenation and combustion. We know that in benzene ring there is a delocalization of pi electrons, means energy is releasing continuously, and this released energy is resonance energy, means benzene is having high stability, means the benzene is having less energy. So after converting it into cyclohexane, it is not easily interconvertible. We have to apply high temperature, pressure, and even we have to add some catalyst. Some energy is also released. This energy is heat of hydrogenation, means the amount of energy released when 1 mole of benzene is hydrogenated and 3 moles of hydrogen is required to hydrogenate 1 benzene ring, and less energy is released. Why less energy? Because our benzene ring is having less energy. When it is converted into cyclohexane, the less energy is released. This low rate of hydrogenation shown that the compound is having high thermodynamic stability. There are some theory about aromaticity, means many theories have been put forward to explain the aromaticity. The first theory is the resonance theory. So this theory was given by MGS Siva. In this theory, he states that in aromatic compounds, all the atoms take part in a single conjugate system and have high resonance energy. Single conjugate system means that the double single bonds are present continuously. They are not crossing each other. Means more the double bond present, more the energy released, and more the energy released, more the stability. Here are some examples like benzene, naphthalene, anthracene, and phenanthrene have high resonance energy. that is 155, 255, 351, and 385 kilojoule mole inverse respectively, and hence are aromatic compounds. Here in ethylene, you can see that the double, single, double, single, double, single, double bonds are present alternatively and single. Here, after this bond, we are going to represent this double bond, not this single bond, because we are saying that the single conjugate system. That's why we are counting it in a continuous way, like single. In anthracene, double, single, double, single, double, single, double, single, double, single. We are not calculating this single bond, but we are going to calculate this double bond because we are telling about single conjugate system. And in similar way, penin 3. So next is limitation of our resonance theory. The first limitation is that it cannot explain the aromatic character completely by itself. Here, you can say that the double, single bonds are also there, but this is not an aromatic compound. Why? We will discuss it later on. The next example is heptafulvene. Has the same resonance energy as that of benzene, but behaves only as a typical polyene and not an aromatic compound. So here, here in heptafulvene, you can see that the double, single, double, single, double, single, double, single bonds are present alternatively, since these are not aromatic compounds. Even though they are having similar energy like that of benzene, which is 155 kilojoule mole inverse, but then it is the typical polyene and not aromatic compounds. The next theory is aromatic sextet theory, and this theory was given by Robinson and Armid in 1925. According to this theory, the aromatic compounds will contain a closed loop of 6 electrons. We all know that the carbon having an electron configuration of 1s2, 2s2, 2p2. In excited state is an electron configuration of 2s1, 2px1, 2py1 and 2pz1. So here s 2s, 2px, 2py orbitals together form a hybrid orbitals, and the one orbital is left unhybrid. These three hybrid orbitals together form sigma bonds like that, and the one hybrid orbitals present as a single electron. These singles electron together join and form bonds like that. So here are the example. Means each carbon atom is giving one electron. So there are total 6 electrons. And this theory also states that the aromatic compound will contain a closed loop of 6 electrons. So due to the presence of closed loop of 6 electrons, the theory was called aromatic sextet theory. So example is each carbon atom in benzene contribute 1 electron, and this 6 electron forms a closed loop. And it is this closed loop which is responsible for its stability and aromatic character. Example, like benzene, pyridine has a closed loop of 6 electrons. In this compound, each of the 5 carbon atom and 1 nitrogen atom contribute 1 electron towards the aromatic sextet formation. Means 5 electrons from carbon atom and 1 electron from nitrogen atom, together 6 electrons, means closed loop of 6 electrons. The next is, however, in five-membered heterocycles like furan, thiophene, and pyrrole, each of the four carbon atom contributes one electron, while the heteroatom means the atom other than carbon, like oxygen, sulfur, nitrogen, contributes two electrons towards the aromatic sextet formation. Now, the limitation of this theory is it could not explain the aromatic characters of compound containing 2, 10, 14, 18 pi electrons. Like naphthalene is not containing 6 electrons, it containing more than 6 electrons, but it doesn't explain the aromatic behavior of naphthalene, anthracene, phenanthrene, etc. Means this theory is limited to 6 electrons only. The next theory is Huckel rule, which is the most appropriate rule to explain the aromatic compound. So, this rule is given by Erich Huckel, and on his name, this rule is called Huckel. He is a German physicist in 1931. Now, according to this rule, any compound will be aromatic and stable if it fulfills the following criteria. The first is the molecule or ion must be plain or nearly so. Means the compound must be plain. The second is the molecule should have cyclic clouds of delocalized n electrons above and below the plane. We know here the configuration, the electronic configuration of our carbon atom is 1s2, 2s2, 2p2. Here, these three orbitals involves in hybridization means sp2, and these one electrons remains unhybrid. So here there are three sigma bonds and the one क्या होगा अनहाइब्रिड इलेक्ट्रॉन होएगा. अब ये जो होंगे यहाँ पे हर एक एटम एक एक देगा मीन्स 6 इलेक्ट्रॉन होंगे यहाँ पर. तो ये 6 इलेक्ट्रॉन्स क्या करेंगे, ज्वाइन हो जाएंगे अपोजिट में और फॉर्म करेंगे एक रिंग लाइक स्ट्रक्चर. अब हमें पता है जो पी ऑर्बिटल होता है वो डम्बल लाइक शेप होता है, लाइक दैट. सो these together joint like this, like this, like this, but they can also join in opposite direction like this, this, and this. So we can get two benzene rings. Here this black lobe represents the above plane and the white lobe represents the below plane. Means the molecule should have cyclic cloud of delocalized n electron above and below the plane. Here you can see the pi electron should encounter all the carbon atom of the cyclic system. Here this circle represent the pi electrons are continuously in motion. The next is the molecule or ion should have total number of 4n plus 2 pi electron, where n is equal to 0, 1, 2, 3, etc. This is the most important line. Here 4n plus 2 pi electron means when n is equal to 0, we are having 2 pi electrons. When n is equal to 1, we are having 6 electrons. When n is equal to 2, we are having 10 electrons. And all these criteria in collectively known as 4n plus 2 rule or simply Huckel rule. In other words, it can be stated as monocyclic, polycyclic, planar, completely conjugated polyenes containing 4n plus 2 pi electrons and having a cyclic pi electron cloud encompassing all the carbon atom in the rings are aromatic in nature. तीन चीजें प्लानर होना चाहिए, delocalization of pi electrons, conjugate system होना चाहिए means, and the 4n plus 2 pi electrons होने चाहिए. And molecules which does not satisfy any one or more of the above condition is said to be anti-aromatic or non-aromatic, etc. The next is applications of Huckel rule. The first is aromatic compounds. The aromatic compounds are those which are having 4n plus 2 pi electrons or having cyclic conjugation. So, what is cyclic conjugation? Cyclic conjugation means double bonds are present alternatively, either with another double bond or with atom having positive charge, negative charge, or lone pair electrons. So, you can see that the benzene double bonds are present conjugately and having 6 electrons 1, 2, 3, 4, 6 means satisfied the first rule and second rule both. Here you can see that this system is in conjugate system and having 2 electrons means all these are having 4n plus 2 pi electrons in cyclic conjugation. The next is anti-aromatic compounds. Means the compounds are those which have not the 4n plus 2 pi electrons and having cyclic conjugation. Here you can see that there are 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons are there. 2 of lone pair. Means they are not follow the 4n plus 2 pi electrons but having cyclic conjugation means they are anti-aromatic compounds. The next is non-aromatic compounds. The non-aromatic compounds are those which have 4n plus 2 pi electrons but not the cyclic conjugation. Here you can see that they are having 2 electrons means they are following the first one but not in the cyclic conjugation means that the double bonds are not in conjugation with other double bond. You have a positive charge or negative charge or lone pair of electrons means the first rule is followed but the second rule is not. That's why they are non-aromatic compounds. Thank you. Means in conclusions, there are many theories put forward to explain the aromatic character. The first one is resonance theory, the second one is aromatic sextet theory, and the third one is Huckel rule. And all these three, Huckel rule is the most justified. Hasif Huckel rule states that either the system is in cyclic conjugation, either 4n plus 2 pi electrons, or either in planar. Means if any compounds following these three rules, they are aromatic compounds. Thank you.